So hi everyone, and welcome to my talk. This would be about annotation processing for Kotlin, obviously, and Csaba Kozák. Let's see our agenda for today, at least from my talk. First of all, I will briefly introduce myself. Then we'll talk about what is annotation processing, how to use it. And later we'll deep dive how annotation processing actually works under the hood. And later, finally, since it's a Kotlin meetup, we'll talk about how Kotlin annotation processing works. So let's see the introduction. About me, I'm the lead Android developer at Supercharge, a mobile agency. We have about 20 mobile developers, and we are also extensively using annotation processors. And this is why I have experience about annotation processors in the second part. In the first part, I have also experience about open source projects, and most notably the Android annotations library. I'm not sure if anybody used that in the past. It's not so popular nowadays, but it was an annotation processor back then. I joined it in 2014, and I worked a lot with annotation processing using this library or developing this library. But that's it about me. So let's talk about annotation processing. But first, I would like to compare and contrast what code generation methods we have in the first place. So in the Kotlin world, we have the Kotlin compiler plugins. These can generate Kotlin bytecode at compile time. So if you have any Kotlin code, source code, it can replace parts of it or even generate new code. If you use Android and use Android Kotlin Android extensions, there are two parts which is implemented in compiler plugins. One is that if you have a parserable class, it can generate the implementation for you. And also, maybe this is in the second talk, but there is a compiler plugin which can generate view accessor for you. Then we have annotation processing, our main topic for this talk. It can generate source code at compile time based on the annotations. Then we have bytecode generation, but in the runtime. So on the JVM, you can actually generate new bytecode. So this code is not written by you before the compilation, but this can be generated on the JVM on the fly. For example, the lambdas on Java 8 are implemented partially using runtime bytecode generation. And also, if you are using testing, and obviously everyone is testing here, then you are using mocking frameworks, and the mocking frameworks also generate bytecode at runtime. And the last method is reflection. It is not really code generation, but most of the annotation processing and code generation tools can be replaced by reflection. It is mainly used now in the backend, where the performance penalty is not really an issue, but on other platforms, maybe a faster method should be used, like compiler plugins to annotation processing. So, to talk about annotation processing, we have to talk about the annotations first. What is an annotation? The annotation was added to the Java language in Java 1.5, and it is also in the Kotlin language from the very first version. So annotation is a metadata which can hold some information, and it can be attached or placed in some places of your source code. So you can put it on a class or a function parameter. Annotation can be useful by itself, but you can also can add one or more parameters to it. If you have only one parameter, which is called value, then you can have this simplest notation, which is in the second line, when you can just add the parameter. But if you have multiple parameters, you have to write those out explicitly, write out the parameter names and then the values. These values and the annotation itself can be read at either compile time or runtime, but because of that, you can only pass compile time constants to it. So if you have a value like a return value of the function, which is computed at runtime, you cannot pass that value to the annotation. If you do so, you will get a compilation error. So annotations are limited in this way. So if we know what annotations are, then we can talk about finally annotation processors. So this obviously takes the annotations as the input and can generate a source code or auxiliary resources or bytecode Java class files. And also those can not just generate some code but place compiler warnings or errors. So if you compile your code that you obviously use sometimes made errors, and you will see compiler warnings and errors, and the annotation processors can place the same type of errors to your code. So it will appear the same in your IDE as well. However, you have to remember that annotation processors cannot modify your existing code. So this can only generate new classes or functions, etc. And why to use them in the first place? So a lot of times there are tasks that are boring, boilerplate code, repeatable, and can be better executed by a machine. So these tasks or this code is better to leverage or delegate to an annotation processor or some code generation tool. So you will not do mistakes, or you don't have to write this boring code like the DI graph or something like that. Also, the annotation processors are running at compile time. So this means if you made errors and annotation processing is written in a good way, then it can raise these errors in compile time. So this way you can catch it very fast, even before you push your code. So these types of errors will never reach your users at all. For example, if you use Dagger, which is an annotation processor, it will validate your whole dependency injection graph for you, and the graph will be complete once there is a valid compilation. Also, there is no real magic in annotation processors. So these are generating source code, and the source code can be read by you. So you can read it, you can debug it, put breakpoints into it. There is no magic, there is no black box. You can read everything which is generated. Moreover, the code which is generated is fast, at least in contrast to reflection. So basically, these are generating code, and at the end, this code is as fast as you would write yourself manually. So there is no magic or no reflection involved at all. And the compilation overhead is not too big. Well, at least in the Java world. We'll see how it is in the Kotlin world. I'm pretty sure that you know some of these libraries which are using annotation processors, but I brought a list to you. So auto value is an annotation processor which can generate a value type, from an interface. It is not very useful for Kotlin because we have data classes, but it was very useful for Java. A butter knife is also an annotation processor. It can generate view accessors for you. The Android data binding framework, which is a very big framework and can do a lot of things, but it is partly based on annotation processing. I talked about Dagger already. It is a dependency injection framework, and it is also this annotation processing. Glide is an image loading library for Android, which has an annotation processor part. Lombok is a very well-known annotation processor in the Java world. However, this is an exception because this can actually modify your existing code. This is done by some magic and internal APIs are used, so this is not a really good example for annotation processors, but still, this is really widely used. Also, there is the Moshi library, which is a JSON parser for Kotlin and Java as well. It is working, is using reflection by default, but there is a CodeGen artifact which you can include, and it will generate the JSON adapters for you. So it will be much faster because it will be as fast as if you would write it manually, those JSON adapters. And Room is an Android ORM, and you can use it. This is using annotation processing itself to generate the code for accessing the database and parsing the models. So we've seen annotation processing examples and what is annotation processing, but let's see how it is working under the hood. So annotation processing is actually, at least in the Java world, it is part of the Java compiler. Unfortunately, we have to talk about the Java annotation processing first because the Kotlin annotation processing is totally based on the Java annotation processing. So to understand the Kotlin one, we have to first understand the Kotlin one. So the Java annotation processing is contained in the Java compiler itself, and it is running in the same process as the Java compiler. So first of all, the Java compiler parses the source code. This is as usual as if it would just compile your code and nothing else to strap. Then it creates a model from the source code. So this means that annotation processor doesn't run on your whole source code, only on the structure of it. So it is interested in the class signatures, the function signatures, the parameters, but it doesn't see the actual implementations inside the function bodies at all. So this model is generated, and then this model and the input annotations are passed to your annotation processors. Then your annotation processor will run, and they can generate code. However, this can also generate new annotations, and those new annotations have to be processed again. So this whole thing is structures into rounds. So if somebody generated a new annotation and there is somebody who can still process it, then there is a new round. And this is repeated until there is no new annotations at all, or there is a compilation error, and then it will fail. So if we have a successful compilation and nobody generated new annotation, then we can resume finally with the normal compilation. There are sources generated by annotation processor, and the Java compiler will compile those to bytecode as usual. So this is how annotation processing works in Java, under the hood, but not in very much detail. So to have an annotation processor, you have to write or implement this interface, or actually subclass this abstract class, the abstract processor class. This has several functions in it, but I added the most important ones here. So when annotation processing first starts, it will call the init function in your annotation processors, when you can do some initializations of your processor. A most important function is the process function, which will be called in each annotation processing round. You will be passed the round environment, I will talk about later, and the input annotations themselves. You can override the getSupported annotation types function, where you can signal which annotations you actually support. So if you have only several annotations, then you will be called for those annotations and not for every annotations in the project. So you can actually reduce your work. Also, if you return a star character here, then all the annotations will be passed to you. You can also have some options or feature flags, feature toggles in your processors, and you have to return the keys of those feature toggles in the getSupportedOptions method. And you can also state which Java language level you support with the getSupportedSourceVersion method or function. So let's see the processing API. We already seen the abstract processor that you have to subclass. There is a processing environment, which is passed in the init function. There are two important parts in it. The first is the filer. So if you generate any new files, and you will if you are writing an annotation processor, then you have to use it using the filer interface. You can write out source code or resources, or classes actually, and you have to use it using the filer. You cannot just place your code in random places, like new file, and write it out, because the Java compiler has to know that you actually generated new code, and it has to process and compile it in the end. So you can only use this filer interface to generate or write out new files or code. As I mentioned, the other output of the annotation processors are errors or warnings, and to emit those, you can use the messenger interface, and there are methods that you can use to place compiler warnings on elements of your code, elements of the input code. So actually you can tell that this function parameter is wrong because you use some annotations in it which should be used on that. So you can place very specific warnings and errors, like if you can see in Dagger. And the second very important object is the round environment. This is created and passed to you in every round of the annotation, every annotation rounds, sorry. There are two Boolean methods which signal whether the processing will be over in this round or whether an error was raised in the previous round. Also, you will get the root elements. This means these are the types that have those annotations that you're interested in on them. And you can also get the types or classes which have some annotations on them. So for example, I'm interested in which types have the inject annotations on them, and I can use the get elements annotated with. And the whole source code is modeled in the element interface. So everything is input into an element. Obviously, the element has lots of subtypes like type element and annotation element and such. So you can visit this whole graph and check which class has which function, and then process that whole structure and put emit code out of it. Obviously, nothing is free. So annotation processing has a cost in terms of build time. And the first cost is the overhead of the processing framework. So the Java compiler has to discover the processors, they have to initialize them, and then it has to run the processing itself. So if you write code in the process method, obviously it has to be run. It's visiting all the structure of the code, it writes out files, it's an input operation, output operation, so that could take time. And also you have to remember that incremental compilation is by default turned off if you have annotation processors on your class path. Incremental compilation means that if you are doing incremental changes to your code, not only those changes will be compiled, and the remaining already existing part of your code will not be compiled again. So this is very useful when you are developing something, but this will be turned off for annotation processors because these processors are usually written in a way that they are expecting the whole source code to be passed in. So by default, the incremental compilation is turned off. However, if you are using Gradle, since Gradle 4.7, incremental compilation is supported even if you have annotation processors on your class path. So if you have processors, they can opt in to incremental compilation, and they can say that, okay, I'm supporting or not supporting incremental processing. There are two types of incremental annotation processors. The first is the isolating type. This can read one element of one type and emit some source code only based on that element. So for example, I have a class which has an inject annotations on it, and I want to generate a factory which can initialize or create a new object from that class. This can be done by an isolating processor. The second type is the aggregating processors, which can be still incremental. These combine multiple annotations into one source code. So for example, if you have a dependency injection graph, this obviously uses multiple types to combine it to one class, which is called in all the dependency graph. So this will be an aggregating processor. However, if you are trying to create an incremental processor, you have to remember that you have to support incremental compilation. So you will not have all the source code passed to you. You will only have the partial information in the partial compilation, and you have to support that. So it's not easy to write an annotation processor that can work in incremental compilation. And unfortunately, if you have only one non-incremental processor in your class path, then the whole incremental compilation will be turned off for your module. So you cannot do anything about it if you have one processor that will kill annotation processing. So if you see this very dreaded warning, this means that, oops, this module has one non-incremental processor, and it will be non-incremental for the whole module. So this is for Room. To avoid confusion, Room actually supports incremental compilation, but only if you use the JDK 11 or a bug-fixed JDK 8. If you are using Android Studio, it will be incremental, so don't worry. And finally, let's talk about the Kotlin annotation processing, because this is a Kotlin meetup. So the Kotlin compiler has an annotation processing, which is abbreviated as KAPT, or kapt. This stands for Kotlin Annotation Processing Tool. So this is actually implemented as a compiler plugin So as I already told you that in Kotlin, you can hook plugins into the compilers, and these can generate bytecode, but also they implemented the annotation processing also as a Kotlin compiler plugin. It works in a way that it first passes the Kotlin sources as usual. However, there is an extra step which is very impactful of your build time. That you have to call the Java annotation processing tool, because the Kotlin APT is based on the Java annotation processing. You have to call the Java annotation processing tool, and that means that you can only pass Java model to it and not the Kotlin model, because obviously it will not understand the Kotlin model since it's a Java thing. So to leverage this thing and to have a bridge over this, first the Kotlin compiler generates a Java stub from all your Kotlin sources and dependencies. Then it will invoke the Java processing tool. The Java compiler itself passes the generated stubs, the Java stubs. That will run the whole annotation processing I talked about in the previous slides, and then the processor source could generate code, even Java code or Kotlin code. If Kotlin code is generated, then unfortunately we have to call the Java compiler again to compile that code to Java bytecode. And finally, if we have Kotlin code, then we have to call the Kotlin compiler to compile the Kotlin bytecode. So there is an extra step, unfortunately, if you are using APT, because APT is implemented in a way that it leverages the Java annotation processing tool. So let's talk about the stub generation. We have this very simple class which should not be written at all. This is just an example. So we have a greeter class which has a constructor, some properties and a function, and it has some annotations in it. And the stub generation will look at this source code and generate this stub from it. Actually, if you go to the build folder in your module, you can find these stubs and I think under the temp or some directory. But if you search for stubs, you will find these stubs generated. As you can see, this is a source code. So as I talked about, the annotation processing is working over source code. And this is also a stub is a source code. It can be read by you or the annotation processor. As you can see, only the structure of the code is actually generated because the annotation processing tool is only working on the structure of the source code, not the method bodies. The method bodies are omitted. So if you look at the getPrinter function or method or the read method, you can see that the function or method instructions are removed because those are not needed at all. However, we are talking about Kotlin, and if we generate a Java stub, how we can model the Kotlin new language features. For example, the nullability information can be added or simulated by annotations, but not all new language features can be compiled down into an old Java 6 source code. So to use that, Kotlin has a very special annotation, which is called Kotlin metadata. So if you have any type passed in for your annotation processor or for an even reflection or at every place, and if you check the annotations on it, you can check whether it has a Kotlin.metadata annotation or not. And if it has that annotation, then you can know that, okay, this was compiled from a Kotlin source code, then I can generate out Kotlin source code again. And this very strange annotation is containing all the Kotlin metadata information about new Kotlin features. It is encoded, so you cannot read it really. However, there are libraries which can use to read the information in a type-safe manner. So if you use this annotation, then you can also see which Kotlin language features were used in the Kotlin source code of the originating source. So we've seen that there are extra steps like generating the stubs or calling the Java annotation processing tool again, then calling the Java compiler, etc. So unfortunately, as I said, that in the Java world, the annotation processing doesn't have too many costs. In the Kotlin world, it does because of these extra steps. So you have to be very careful when you are using annotation processing with Kotlin, and you can either mitigate these problems or maybe you can switch to other methods. So how to use the Kotlin annotation processing tool as a developer? So in Gradle, you have to apply the Kotlin kapt plugin. Then in the dependencies block, you have to list all your annotation processors in the kapt configuration. If those processors have some feature flags or options, then you can pass those in the arguments block. Also, I really encourage you to add this Csaba option xmax errors. This is because some processors can generate lots of errors. And unfortunately, in the Java compilation, the number of errors is limited to 100 by default. And if the real error, the root cause is 101, you will not see it at all. So to see it, just increment this number to a very big number, and then at least the error will not be lost. You can find it in the loss of errors. It is hard, but at least it is there. So I suggest to you to turn this on, and actually this is suggested in the Kotlin kapt official manual as well. So this was the basic usage of kapt, and to make it as fast as possible, I suggest the following things to be turned on. And first of all, please use the latest Kotlin compiler. This has the latest and greatest features, obviously. However, you have to know that incremental annotation processing is also in the latest compiler. It is enabled by default in 1.3.50. But you can further enhance Kotlin compilation using Gradle properties flags. The first flag is used to enable compilation avoidance. Compilation avoidance is also a way of incremental compilation. It is actually avoiding compilation of the whole module if it can be avoided, when the module is not changed, and also the dependencies are only changed in the method bodies, then the whole compilation can be avoided for that module. To enable that, you have to turn this flag off. This actually remove the discovery of the annotation processors, and then you have to list the annotation processors directly or explicitly in the dependencies block, like here. Then this way you have compilation avoidance even if you have processors. Also, please turn on the worker API. This is a new API in Gradle which will enable faster compilation. And also, if you have parallel build in your Gradle project, you can also enable parallel Kotlin compilation tasks. So if you have multiple Kotlin modules, those can be compiled in parallel. Also, check all of your annotation processors readmes or instructions, because in some processors, you have to manually enable incremental compilation. There are two known processors. First is Android data binding. The second is Room. Both of them have to be enabled in some way, either with Gradle flags or annotation processing options. And obviously, you have to use the latest and greatest processor versions, because those can contain incremental compilation. Also, if you have non-incremental processors like that Room one in the previous slide, you can move it to another module, so only a very small part of your code can be affected by non-incremental compilation. So how we can mitigate the very big overhead of kapt? First of all, you have to avoid the generated Java code. So even if you have a poor Kotlin project, but you have an annotation processor which will generate Java code, as you could see, we have to invoke the Java compiler also. So to avoid that, please don't use annotation processor which still generate Java code. Also, make sure to process incrementally, as we've seen in the previous slides, and also leverage the compilation avoidance. And it would be useful to scope the annotation processing to the smallest module as possible. So the problem with stubs, they are generated for all of your code and all of your dependencies as well. So if there is only one module in your app with lots of dependencies and lots of source code, then the stubs generation will be huge. So, but if you only have a small module which has annotations like a diagraph, then the stubs will be generated for those very few classes. So it would be useful to remove and move this code which will impact the stub generation to that module. If you are trying to write an annotation processor, it could be hard if you just look at that API, but you don't have to remember the wheel. There are libraries which can help you. The first and the most useful is Kotlin port. This is by Square. This can generate Kotlin source code dynamically. Also, you can use auto service, which can use to automatically write up annotation processors. There is an incapt library, which can help write incremental processors, and the Kotlin metadata library, which can extract that very strange information from the Kotlin metadata annotation in a type-safe manner. And if you are doing testing, and you should do so if you are writing processing code, then you can use the Kotlin compile testing artifact to test your annotation processors. Let's see two examples for the first and last library. So to write code, you can use the Kotlin Poet library. This is a very simple usage of it. You can create so-called specs, and these specs can contain all the information about the elements of your code, the generated code. You create a class, a file, and then you add functions and instructions inside functions. Finally, there is a model in an object, and then you write this model out, and then you have generated Kotlin code. And don't worry about imports. Those will be generated automatically. You don't have to add those. You can check the usage of it in GitHub. And also, if you are testing your processors, testing can be done in a way that you are writing the input source code, which is actually the code that would be written by your users or developers, of course. And this code will be containing an annotation. You will actually compile this code using the Kotlin compiler, and then the compilation has a result. It can have messages, and the output is the source code. And you can check the result, the messages, and of course, which source is generated by you, and check that it is the expected thing that you generated. So this is how you can use testing in annotation processors. Kotlin has a very great thing lately. It gone multi-platform. This means that you not just are able to write JVM code, but also can target other platforms like JS and native. However, as I said, the kapt is a Java-based thing, so it cannot work in a multi-platform project. But we can still write annotation processing source for multi-platform projects. There is a new library. This is called npapt, which can help you with that. So this has an API which is not tied to the old Java APIs at all, but a new API which is copied from the Java one, but not related to it. So if you write a processor that way, then you can generate code for the multi-platform projects which target native, JS, or obviously JVM as well. But you can write one processor which will use these platforms, all of these platforms. This is a new project, so be aware of it. And only 2 known processors are written using this project. I gathered some useful links for you. The first is really an intro for annotation processing by Hannes Dorfman. The second is the Java plugins manual about incremental processing and annotation processing in general. And there is the reference about kapt in the Kotlin official documentation, and the great article on Medium about how to use incremental compilation, as I outlined in the previous slides. And there was a great article by Uber engineers who measure the Kotlin compilation performance, including annotation processors. The last articles about that. So thank you very much for your attention. And if you are interested in using annotation processors, you can join us. We are hiring, and there is the email address below. And thanks again. If you have questions, please ask me.
I haven't used annotation for quite some time, but I remember that you can put annotations on local field declarations as well. Can you put that in? At least in Java.
Maybe in newer Java language levels, but that definitely will not be processed async, because, as I said, that only the signatures of the function will be modeled. Those are for the Java compiler. not for the processors.
You have mentioned that you're aware of 2 projects using MPAPT. Which two of
Those are listed in the MPAPT GitHub, very small projects, but you can check it out on the MPAPT GitHub. Nothing really interesting yet.
Right, so it's not like dependency injection?
No. Not yet.
All right.
No further questions? Hi, thank you for your presentation. My name is Tom. You mentioned that in order to leverage the cost of having multiple annotation compilers to module, to put source code related to those annotation compilers in separate modules, right? So do you have any example, like from your experience?
Yes. So, for example, if you have a DI, you can. This is maybe not a good thing for a programming experience, but you can put all of your DI information in one module and run Dagger in that very small module, and don't put DI everywhere. And please only use the inject annotations in your modules and the library modules, and have one module which will be used which will compile your components, because the inject annotations will generate factories. Those can be isolating processors, but the component annotations has to be aggregating processors. So this way, if you put the components into one module, you can have a smaller impact by stub processing and annotation processing as well. Or if you have a database and you are using Room, you can move all your Room code to a dedicated artifactor module, and then run Room only that in that module.
And with Dagger, it doesn't sound like an easy task, because it could be like a Swiss knife used for everything.
Yes.
So it's more like a question how you overall structure your code base.
Yeah, of course. Yes. So you may have to sacrifice other things to leverage the most powerful annotation processing speed in your build.
So you can imagine like you would still have this app module, library modules, and everywhere could be Dagger. Just because you're splitting it in small library modules, that's where you cut the cost of having it like influencing your build time, right?
Yes.
Because you don't modify those. So
Indeed.
more like taking advantage of Gradle ecosystem for this purpose.
Mm-hmm.
Okay, thank you.
Welcome.